So we're going to finish up moles, and several people have actually already done the lab, lab 6. So there is a pre-lecture, which was this page, and this is looking like it's out of focus. Let's see if it focuses for me. There we go. Yeah, so the lab, you have to look at, there's a video, it's like a 15-minute video of me in lab doing the lab, and it pretty much, it gives you pretty much the whole first page of the lab. You just have to do the calculations, and I do not do very good, so you should get a not great % error. The biggest questions that have been asked about the lab is that the end of the first page, when you calculate my % error, you will get a negative, but the formula has 2 lines on it, and that means absolute values. So you do an absolute value, so it does come out as a positive %. So it does come out somewhere around 10% or a little bit higher. And that's actually because the spectrophotometers have not been calibrated. And so when you guys would have done that in class with me, usually 2 of the spectrophotometers are much better than the others. And I didn't want to try every single one to get the perfect results. I figured it was actually good to have not great results. And yeah, I did want to remind you, I thought I asked the question in the pre-lecture video, but I must not have because nobody has emailed me. I mentioned it in class, but there is, if you want to email me, so you can email me your favorite mole joke. There, it has to be a chemistry mole joke, and you'll get a bonus point for the next quiz. So it has to be done by Tuesday. So anyway, find a mole joke and let's go ahead and get started. We did the first page, problem solving. So let's do the other problem solving page. And again, I don't know why. I've been having trouble with my camera. It's a little bit out of focus, but and then there'll be a study set that I will post hopefully today. If it's not there, somebody can email me and remind me, hey, when's the study set going to show up? But I've been really impressed by people who've done the lab and turned it in, that you guys picked this information up pretty fast, which is really good. So 1 billion silver atoms. And so a billion is 10 to the 9th. It would mean 9 zeros. So you can either write it like this, 1 times 10 to the 9th. You can write it 1E, capital E9, as opposed to Steve Jobs' iPhone, which writes it as a little e. Can't believe that their iPhones actually do that, thinking it's cute, because little e and capital E are not the same thing. Or you can just simply write it as 10 to the 9th. Writing it out as a 1 with 9 zeros is a little tedious. So my other class, they have their next celebration next week. So they were asking me questions. Do we need to know anything from the first exam? Is this over everything? You know, scientific notation, we're using the metric prefixes. We're doing this railroad tracks, which was one of the big things from the first exam. And so we keep building on stuff. But yeah. I don't know if that's a question you were wondering. All right, we want to write the unit, which is atoms, and it is helpful to write what type of atoms. Silver is Ag for argentium. Anybody know why it's called argentium? Probably not. I do, but this is a good moment for me to remind you, and somebody can also remind me by an email because I keep forgetting. I thought of it this morning. You guys do have, it's a short paper. It's like 3 pages on an element. It's due in about a month, and we will be doing class presentations. So we'll negotiate that. That will be on Zoom. There'll be 2 different times that you'll sign up for. And so you're going to pick an element. So silver, and you can figure out why it's called what it is. So why is silver Ag, argentium, which is why Argentina actually was also called Argentina. Has to do with, they thought there was a lot of silver there when the Spanish conquistadors first came, but they were wrong. anyway, so I'm going to be bugging you more next week to start picking your elements. Nobody's picked one yet. So if you pick, you can send me an email, or you can even shout it out right now, and you would get first dibs on whatever element. Pick something that you don't know much about, but yeah. All right. We pull the unit down, atoms, and this is where Avogadro's number comes in. So it's right there on the top of the page, little mole writing it, and it is that 1 mole is 6.02. Again, I recommend you go with 4 sig figs, but I know at least half of you, this is the only chemistry class you're going to take, and so if you're a 3 sig fig person, you can go with the 3 sig figs. So this number is going to go on the bottom, and the unit is atoms after it, and we would want to use parentheses. So yeah, that 1 mole is that. I always go to moles, and that's because we're going to start adding an extra step, which was with molarity, going to liters, or the mole to mole step, which does show up eventually on this page. And then we can change that mole to grams. And this is the step. So whenever you go from moles, you can go to Avogadro's number, to atoms or molecules. And that's always with Avogadro's number. So we'll just say Avo number. You can go back and forth to grams, and that's using the periodic table. We also found we can go back and forth to volume, to liters, and that's using molarity. There's these charts online, and there's so many places we can go, and we're going to keep building it. There's another place, but I didn't give myself enough room, which is using a mole to mole ratio. But this step comes from the periodic table. And so silver, this is also something from the first month of the term in October, is you should be familiar with your elements. Yeah, you can have a periodic table with the names, but hopefully you know Ag is silver, and we see the number there, 107.9. Again, I recommend 4 sig figs, but you can go with 3 sig figs. And we would punch it in, and look at that. My answer actually has 4 sig figs today. Oh, I'm sorry, we have one more step, which is grams to picograms. So that chart of your metric conversions, they show up a lot in your study set and with this work. So keep it familiar. I like to do it the way the chart is, that we say 1 picogram, 1 nanogram, 1 microgram, 1 kilogram, and then pico means 10 to negative 12. Again, for those of you who are going to be taking a full year of chemistry and biology and physics and organic chem, you do run into these prefixes. So learning them rather than always being dependent on the chart, we use them enough that you really do. And that's one of the things that students will often joke by the end of 221 or 222. They're just like, oh yeah, I just know them because we just use them so much. All right. So question number 2. There's caffeine, and a question that often comes up, again, I'm not sure why my focus is going off, is the order that the atoms are shown in a chemical formula. It is something that I actually talk about next week. There is a pre-lecture video for next week. We're going to be doing Lewis structures. So we're going to be drawing out what these things look like in 3 dimensions. So there is a pre-lecture, and then in the lecture on Tuesday after we go through the study set of moles, yeah. All right, so next week's lab is, again, it's going to be drawing a lot of stuff. We have 123 milligrams, and we want to know how many molecules. So using color can often help too. I don't know where my pink pen is today. All right, so I have 123 milligrams. I'm going to go ahead and write out the formula, C8H10N4O2. You didn't necessarily have to do that, and so I don't make the same mistake as my last one. Writing down where you're going to, giving yourself enough room. I found realized last night when I'm teaching, I write bigger because just from 25 years of doing it. And when I'm doing it by myself, I actually write much more delicately. All right, we have to get to grams because the periodic table works with grams. So you can either say 1,000 milligrams on the bottom to 1 gram, or milli means 10 to negative 3. So if you do it that way, the 10 to negative 3 is with the grams on top. So now I have to go grams to mole. In this step, this is the periodic table. I don't need to see how you got to this number. I will know based on the number. And then we can change our moles to molecules. Comment that I made the other day, and this will always hold true. Mole always gets a whole number. In this case, with almost all of these, it's going to be the number 1. The only time it's not a 1 is if it's a mole to mole ratio step. And we'll see that on the last 2 questions here. All right, this is Avogadro's number. I recommend that you write it out, but you can do that abbreviation I showed you. I'll do it at some point on here. Comment on the first one. When you divide by this number, most of you on your calculator will need to use parentheses. That way the number, you divide by all of the numbers. So you should, if your exponent is not the same as mine, that is usually where the mistake is, or with the metric conversions. So you can go ahead and calculate that or add up these numbers while I do it. I purposely did not do it before so that we would have the time. And so you just take the 8 carbons, the subscript 8 for the carbons, and you multiply it by the number on your table, 12.01. And then you add 10 hydrogens times its number, 1.008, plus the 4 nitrogens times its number, right? So 14.01, and then plus the 2 oxygens times its number. And we should all get the same thing. Again, you're either going to pick that you're going to do 3 or 4 sig figs. If you're going on to the 200 level chemistry after this, 221, go with 4 sig figs, because in that class we always do 4, but that's only usually about half of you. So that's what our setup looks like. I'm limited to 3 sig figs because the number I started with has 3. Avogadro's number, how I'm writing it, has 4 sig figs. My periodic table has 4 sig figs. So my answer, though, will only have 3. Your exponent has to be the same as mine. Now, if you got 3.83, that's fine. This last digit is in this set of stuff that we're doing. The last digit sometimes will vary based on how you're rounding with the periodic table. So if you got 3.84, that's fine. If you got 3.81, that's fine. But it has to be e to the 20th power. All right, next one. So melatonin. Melatonin is amazing. So endogenous means it's it's in us. Endo means inside. And so your body makes melatonin. I'm not actually a fan of people necessarily taking the supplement, because there's a question if that actually ends up causing your body to stop making as much. But it is actually an antioxidant. It is the strongest antioxidant, I'm pretty sure, stronger than vitamin C. So we're going to get into oxidation reduction, I think, in 2 weeks in this class, 2 or 3 weeks. Anyway, and that's what it does. So while you are sleeping, that is why sleep is so important. Your body is repairing itself. So melatonin, actually, we think of it as a sleep hormone that it helps you to sleep. It's actually going around and repairing your body. It is extremely affected by waves. And so every time we have an engineering great feat, like when radio waves and microwave communication happened, so during World War II with microwave communication, there ends up being a problem for people. And so right now with the Wi-Fi and are moving into this global Wi-Fi network, sorry, I can't remember the name right now, a lot of animals are having trouble with their migrations because of that. It is something that always happens and then everything goes back to normal. But if you have trouble sleeping, it could be if you just got a new Wi-Fi. This happened to me in the spring term. Joey got a better, it looks like Batman's Wi-Fi, and I could not sleep for 2 weeks. I felt like a zombie. And it turned out it was the Wi-Fi and the waves. And so we programmed it so my Wi-Fi turns off at nighttime. And like the next day I was perfectly fine. But I'm trying to remember, there's a guy who's actually a cult classic now. He was a scientist and he got into this. And so the scientific community said this guy's crazy, but it's also why your animals know when you're coming home. If you've never heard this story, it's like your animals, like my cat knows when I pull an avocado out of the refrigerator, no matter where he's sleeping in the house, he will be in the kitchen in a moment. But this guy actually got into some of that stuff, and that is all related to melatonin. It's a lot more than just sleep. All right, so that was me just talking. You can listen, or you could have solved the problem. Sometimes I just talk in hopes that you'll solve the problem, but you might have been mesmerized. So this problem also is a little psychological test for all of you. And so I can't see anything but black boxes, but even when you're listening at home, this fascinates me. How many of you had to count how many zeros were between those two ones? And how many of you were like me and you just wrote a random number of zeros? Because it doesn't really matter because of the decimal. That was just me because it's about a 50-50 mix, and it just has to do with a certain part of how our brain thinks. But that's all right. My house is always a mess. My room is a mess because the number of zeros there doesn't matter to me. All right, we're gonna go, we have to get to metric. So again, from the first celebration of learning, from the first part of the term, we might run into some of those things, which is this factor label. And so there's our conversion that 1 quart is 0.946 or 0.9463 liters. And that gets us to liters. And then I'm gonna have this piece. Having a highlighter or different colors, I found my pink pen. So this is milliliters. So 10 to negative 3 liters is 1 milliliter is how I set it up. You can do 1,000 milliliters to 1 liter if you prefer. That gets me to milliliters. Now I'm gonna bring this piece in. 99 picograms per milliliter is actually how much melatonin is cruising around. And the question wants us to get to molecules. So molecules means Avogadro's number, means we have to get to moles, means we need to change our picograms to grams. Again, using the chart, pico is 10 to negative 12. Then we have to do our grams to a mole. And 1 mole is Avogadro's number. So I'm just going to write it as NA. So a capital N subscript capital A is the abbreviation for Avogadro's number. I mentioned this the other day. The most missed piece on this is showing your unit. So please make sure there's a unit with Avogadro's number. In this class, it will be atoms or molecules. So did anybody calculate this number yet? I have to go through it. Maybe. So you may have a question while I'm adding it up. And our final answer is only going to have 2 sig figs. So we're adding up that this number is coming from the C13, H16, N2O2, which is the chemical formula of melatonin. It is going from the least electronegative to the most electronegative. And so that term electronegative is our next lecture, the pre-lecture. It's which ones are the greediest, the most desperate for electrons. And that would be moving towards oxygen. It's the driving force of life. All right. Maybe it's because it's dark. So this happened on Tuesday. That helped it focus. As the weather came in. Nobody got it? I don't know if anybody's there. All right, we'll have to go with my number. So 232.3. Somebody else get that? In class, at least somebody nods at me.
I got that.
Okay, thank you, Christian. So we just punch it in. And that's the idea. All right. So the next one, we have one place to start. And this one has a mole-to-mole step. And I'll show you why I know that in a moment. So the abbreviation for grams is just G. Hopefully you all remember that. And what we're solving for is atoms of oxygen. And I mentioned this at some point. When I write oxygen, I think it was in the pre-lecture for this, I put an X through it. Otherwise, sometimes students think it's a 0. And so it's a really nice trick. I had a student teach me that 20 years ago. I know this one has a mole-to-mole step because it starts with the whole compound and then it ends with just the oxygen. So our first step is we want to change our grams to mole. Now, my recommendation, that gets rid of the gram. That would get us now, we'd have moles of aluminum nitrate. When I see I'm going to be having a mole-to-mole step, you want to label your work more completely. So on the previous one, I just kept it as a single unit because it never changed from melatonin. Same with up here. I stopped writing my full formula. But in the mole-to-mole steps, we do need this because our mole of aluminum nitrate, this is going to be around 213. You may have more digits like 213. Like on the previous one, if you went with 4 sig figs, that's great. If you went with 232.278, I always have some students who like 6 sig figs, that's fine too. In the end, we ended up with only 2 sig figs in our answer. All right, we're going to have a mole-to-mole step. So it's the idea you can only change 1 unit at a time. Our problem again has 2 changes. We're going from grams to atoms, and we're also going from the whole compound, aluminum nitrate, to just the oxygen. So here I changed grams to mole, but it stayed as aluminum nitrate. Here I'm keeping the mole, but I'm going to switch now from the aluminum nitrate to just the oxygen. And this has to do with how many oxygens there are, which is 3 times 3, which is 9. So parentheses mean multiply. I've learned that forever and ever. So there's 1 aluminum, 3 nitrogens, 9 oxygens. So this is a whole number. Mole always gets a whole number. We only put that 9 once in there. That's good. When we did the mass, it was of the whole compound. We don't care about the mass of the oxygen. All right, and then 1 mole of anything, in this case of the oxygen, is Avogadro's number. And again, you can write it as the 6.022 times 10 to the 23rd, or you can just write that abbreviation, capital N subscript A, which is a really nice shortcut. And we don't have to deal with metric prefixes here, 3 sig figs, because that's what we started with. So questions, that was, sorry. So this step, this 9 is coming from the subscript. So if I'd asked for nitrogen, that would have been a 3. If I'd asked for aluminum, that would have just been a 1. All right. I assume that you guys got this because you did really good with the math on the last test. And so if you've been putting the time in, we just keep building on it and it's really not so bad. All right, Oh, I gave you the compound. So polyatomics. How was everything? I did this morning grade most of, I think I went through all the quizzes and labs and stuff that people submitted on Tuesday. I learned that it's really hard for me to write notes in the naming part, just it's awkward and I'm not very good at it. So if I wrote a note on yours and you can't figure out what it's supposed to say, just come to office hours or stay after today. We'll get done early today and I'll have the office hour open until 2 o'clock-ish. And then I have one again tonight and just say, hey, can we look at my quiz? And we can look at that. All right, so this is this compound. This is picolinate. So there's millions of polyatomics. And that's all that was. No, I'm still going out of focus. All right, C6H4, NO2, everything inside that parentheses is going to get cubed. I'm sorry, it gets multiplied by 3. So there are 18 carbons, 12 hydrogens, 3 nitrogens, 6 oxygens. Yeah, it's gonna have pretty good mass. So the question wants us to go to micrograms. So let me write it mcg of just the hydrogen. So again, micro, you can do the mu. This is milligrams. So our first step, we want to change our milligram to grams. So again, find your way of working with metric. So I'm trying to be consistent using the chart, but again, you can do 1 gram is 1,000 milligrams. And then we need to find the mass of this whole compound. You can write it out again, or you can you can call it CP wouldn't be a good thing to call it though. And we're gonna go to 1 mole. So anybody figure it out? This be your bonus point. If whoever figures it out, give me a number. If anybody's there.
Oh wait, are you asking for like the
mass, the molar mass of the chromium picolinate?
418.3.
418.30.
Yeah.
You're good.
I just.
Oh, you're fine. That's fine. Did anybody else get that? Is anybody else there? We're gonna assume he's right. Did you get my final answer then, Christian? Because if you did, then we're good. All right, this is of our whole compound, chromium, blah, 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 blah. So now we have our mole to mole ratio. For every 1 mole of the chromium, C6H4, NO2, 3, I want just the hydrogen. So how many hydrogens are there? There are 12. So 12 moles of hydrogen. Now, one of the things that happens, the students get in a pattern and they then want to use Avogadro's number. They're like, okay, I'm going to have this extra piece here. This question does not use Avogadro's number. So how do we know? How could I could tell from just looking at it from the beginning that there was no Avogadro's number.
We're not going for molecules or atoms.
That's right. Who is that?
Damon.
That's what I figured. Yeah, Christian and Damon answer all the questions. Somebody else should answer once in a while. But yeah, if the question does not ask about atoms or molecules, like on the previous ones, or start you with atoms or molecules, we're not using Avogadro's number. So just realize that. Now, there's also, we don't always use grams. We don't always have to use the periodic table. So there's actually one on the lab where you don't use the periodic table. Periodic table is when we're going to grams. So if the question doesn't involve grams in any way, we don't have to use the periodic table. We use other things with the moles, but remember there's different places we can go with this. All right, and then our last step, we're gonna have 2 more steps. Gnome got in the way. That 12, by the way, only shows up one time in the mole to mole ratio. That is the key to this whole thing. When you use the periodic table, it is always 1 mole. And so it is hydrogen, so it's 1.008 grams. There is another way to do this one. Actually, I think on the next page I show you. But this, I wanted to do the factor label. And so this is, one of the things I found is whenever you're in doubt, if you go back to this railroad tracks, it works out because it's all in the units. And then 1 microgram is 10 to negative 6 grams. And you should get my answer. I had at least 4 sig figs the whole way through, so 4 sig figs. Are there any questions from that page? All right, so you guys are now masters of moles. You're all not answering because you're busy like laughing, looking up mole jokes. So molarity, this is what your lab's about. And it's a really good lab. It's a really fun lab, and I'm sorry that you guys can't be in lab. There's nobody in lab. It's very quiet. It's a little sad because it's so quiet. But let's go ahead and go through the conversions. Again, several people have already done the lab and turned it in and said it wasn't too bad. You do have to watch my video to do the first page. I pretty much walk you through it. You just have to punch the stuff in your calculator. And then the post lab is just like this page and the next page with empirical formula. All right, so the key with this, the key with molarity is if I give you someplace else to start there. So if I give you grams or if I give you volume, start with that. This, instead of thinking it as M, the big M, change it so it's moles per liter. It is a conversion factor. It is a way to go between 2 units. I like my other pen better and I can't find it today. All right, so grams, we're gonna use the periodic table, change our grams to moles. I think this one's like 212.3. I do want to remind you guys of something with the periodic table while we're talking about. When you do potassium, I do recommend you do 39.1 or 39.10. Don't round it. But if you're doing sodium, sure, 22.99, you can round that to 23. But magnesium, don't round that. That 0.3 can make enough difference when there's several magnesiums. Same with like over here, oxygen, yeah, 16. But sulfur, I like to keep the whole thing. Wait, you play around with that. So I have to add up my numbers. Yeah, so 212.3. And I don't have a mole to mole step because it doesn't have me break that out. I'm going to now use the molarity. So no use of Avogadro's number, as Damon said, because it doesn't ask about atoms or molecules. So molarity is always moles per liter, but it's a conversion, just like what you did. This is why we spend so much time. Those of you moving on to 221, this is going to help you so much because you have this pattern. Actually, the second half of the term, that's why that lab was there. So the same with the naming lab. It is another one of those humps. So you guys have the idea of the math. That makes the mole stuff pretty straightforward for you. And then feeling comfortable with the naming, because I know where we go from here in 2 weeks. That will make a big difference of putting the ions together. And again, today is the day I have a lot of office hours. So just taking the time to come in and asking a question. We wanted to get to milliliters. So again, 10 to negative 3 liters to 1 milliliter. And 3 sig figs because we started there. All right, this one wants us to go to grams of sodium sulfate. And we're starting at 321 milliliters. And it gives us, I have a fruit fly that's joining our class. All right, it works with molarity. So molarity is liters. So 1 milliliter or 1,000 milliliters 1 milliliter is 1,000th of a liter. And then I bring the molarity in, 0.456 moles to 1 liter. And this one you want to be careful with because it is just of the sodium. So we're going to have that extra step because my answer wants of the whole compound, but right now I'm just of the sodium. So you don't want to go to grams yet. I don't care about the grams of the sodium. I care about the grams of the sodium sulfate. So 2 moles of sodium for every 1 mole of sodium sulfate. It is shown as the ion. That's not going to make a difference in the math, but we're talking about a solution. Again, I mentioned this at the top of the page. These things are aqueous. They're mixed with water, and so the ions have pulled apart. So our ions are sodium and sulfate. So for every 2 moles of sodium, I have one. For every 1 mole of the whole compound, there's 2 moles of sodium. And then for every 1 mole of the sodium sulfate, this mole to mole step, you do have to have it fully labeled. I recommend your other steps are, this should be 142-ish. You can again have 4 sig figs. I'm just going off the top of my head. I could add it that fast. All right, so 10.4 grams. Questions? Again, I don't care about the mass of the sodium. I want the mass of the whole thing. So figuring out they have 46 grams of sodium does us no good. All right, this last one was there because on the lab you do a dilution step and it walks you through it with the lab. So just take the time. Normally would have been together for 2 hours in lab, probably won't take you that long, but watch the video. Do it before 6 o'clock tonight. So that way if you have questions, I have those office hours tonight from 5 to 7 that you can come and check your lab with me and know that you get 15 points. All right, so what's going on here is, and I know it's a dilution problem because it says that, so it's the one part of the lab that we have 0.123 molar of sugar solution and we have 555 milliliters. And then I want to know, somebody already has it. So this is really nice in lab. We often have stock solutions made up. It's kind of something I'm betting on this weekend when I go into videotape that everything's still back there, that I don't have to make stuff from scratch. Last weekend I kind of had a disaster going into lab because none of my demos worked. That was from my other class. So anyway, I told them I deserved a virtual standing ovation by the end because I finally got them to work. And then what we're trying to find is the new volume. Now you can just set it up like this. We would divide by the 3.33 and so this is my concentrated solution, higher concentration. This is diluted. Now the biggest question, or the question I have for you, has to be somebody other than Damon or Christian answering, is why on these up here I always had a liter involved, but here I just left it as milliliters. Why am I not worrying about changing my milliliters on this one, even though I'm working with molarity? This is actually a really important take-home question. Anybody? Any ideas? Anybody awake? It has to do with, since we're not doing the factor label, we're not actually canceling out the milliliters. So as long as my volumes have the same unit, they can be any volume unit you want. They can be cubic feet, they can be liters, they can be kiloliters, they can be quarts, pints. So whatever this unit is, that's my final unit. And so we just need about 20.5 milliliters of the concentrated solution to make up this one. So that's it for molarity. I wanted to do, we talked about, oh, I do have that problem on the top of the page, empirical and molecular formula. So I'll go through a percent composition one, and then I wanted to do one more empirical formula. The The percent composition is, so we're going to do aluminum sulfate. So aluminum, you guys should be your masters of nomenclature now. Aluminum is a +3. And then sulfate. So again, I can't emphasize enough. And this is actually a question, and I noticed that several of you didn't turn in the lab. And I am generous this term with that. You can turn it in late. You do get a point deduction. But some people did say to me, I want to go over it with you in office hours. I know I have questions on it, and that Thursday is the day that I have more office hours. So I can't emphasize enough, you need to renumber your periodic table. What we're doing next week, I pretty much tell you, if you haven't already, that these A group numbers are actually the key for doing the Lewis structures that we're doing. I also recommend that you write your charges in there. So the halogens are a -1, oxygen's family, the chalcogens are -2, nitrogen's family is a -3, etc., because that will help you. Aluminum is below the staircase, so it becomes a positive. And then also making a nice list. Again, there's huge lists online of polyatomics, but if you learn, the students who are the most successful, they restrict themselves to just the 6 that I told you on page 2 of your lab, and they make themselves a nice little chart of adding and taking away oxygens, because then you understand the pattern, and it will help you then as we move on to this. But here we go, aluminum sulfate, the charges, then switch down, our final answer, and we need that. So we could do this factor label. So the question wants to know by mass how much aluminum there is in the aluminum sulfate. So what we know about aluminum is it's 26.98, or you can say 27 grams per 1 mole of aluminum. I'm going to do this factor label. Usually I can't remember how to do it factor label. So that's what we're trying to figure out, is the percentage of aluminum by mass, which means gram per gram. So what we know is there's 2 moles of aluminum for every 1 mole of the compound. That again is the subscript, that there's a 2 there. And so that cancels my mole there. And then what we know, our next step would be for every 1 mole of aluminum sulfate, we would add that up, and that was one of the ones I did in the pre-lecture. It's 342 point something. I don't remember what the point is, grams of aluminum sulfate. And that is the idea of these percent questions. I don't know that we actually have one in the homework. And again, if it's, I will get that up there today. But you end up with grams of aluminum over grams of the total, and that's what the percent means. The percent means the grams of the element over the grams of the compound. And then to make it a percent, you multiply by 100. Some of you multiply by the 100, some of you just move your decimal. So that's kind of up to you. So the compound's around 15.8% aluminum. All right, I want to do, I made up another empirical formula, so we'll do this one. And just for practice, and then I will hang out. So those of you who want to work on the lab or have questions on either the naming lab or the lab that's due today, which is on moles. All right, and so you can just do this on a piece of paper. So we're 47.26% copper and 52.74% chloride. So our first step, step 1, is make it grams. So we assume it's 100%. I'm sorry, it's 100 grams. Percents are out of 100. So we just change this to grams. Just change your percent to grams. That's your first step. Your second step, step 2, is, you don't have to write step, 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 but is you want to go to moles. That was the whole point of this week and the lab and stuff. And it is really why the celebration of chemistry, because moles are awesome and there's really fun mole jokes out there, or cartoons, or you make an original. All right. Periodic table. This is the step. So we take showing your work, right? So we're in this environment, which means you guys show your work even better than they did before. I also want to make a comment. There's like there's two of you. Might be a third one. Some of your pictures you're sending me, I'm having trouble reading them. It is really your responsibility to make sure when you submit that it got submitted, and then to look at it to make sure it's readable. And if it's not, you have to resubmit. So I'm going to start taking points off, because if I'm like spending a half hour trying to read what you submitted just because you're so careless and didn't try to take a better picture, and to say that it's your camera, there's how many people in your life, everybody has a camera now. The state gives them out apparently for free to everyone. All right, so copper, 63.55 grams from the periodic table. And this is, again, this is the question you asked me, Spencer. That is what grams per mole. We're just flipping it so our units cancel out. And then chlorine is 35.45. I've emphasized it today, and I emphasized it on Tuesday. Don't round the periodic table. Keep at least 3 sig figs, if not all 4, and that will save you a headache with these. So I recommend 4, but if you want to just do 3, because that's what you want to do, that's fine. Having more actually ends up causing more problems because you get lost in all the numbers. All right, so 0.7437. You're just punching this in your calculator. So in class it would be fun because I could see everybody would have their calculators. It would keep them awake. All right, and this is 1.488. These do have units. We'll just say moles. I can see this is my chlorine, this is my copper. So step 3, we have colors, is divide by the smallest. So what we're trying to do with empirical formula is we're trying to find the subscripts. And the subscripts are always whole number ratios. So we're trying to find the whole number ratio. So that's why we divide by the smallest, 0.7437. So one of them always comes out as 1, not necessarily our final answer, but in this step, and 0.7437. Oh, is it going to be a 1 to 0? Picked the wrong question.
I got 1 to 2 ratio.
It is, yeah. So it comes out as 2.0000. So it's a 1 to 2 ratio. So the fourth step, so step 4 is where you have to multiply by a factor to make them whole. The ones in the lab will give you practice at doing this, and then there's a whole page again on your study set that I will get posted up there. This step is not necessary on this example because it is whole numbers already. So our answer would be Cu, just one of them, and then 2 chlorines, which is legit. That works. I don't know why. I was thinking it's because it's chlorine. I was thinking it was something else. The name of this compound, just to practice naming, copper would get a Roman numeral, and chloride, that IDE ending is just because it's not a polyatomic. So since the Cl has a -1, the copper then would have a 2. So the name would be copper 2 chloride. Just fun with naming of the stuff. All right. Any questions? Again, there is a pre-lecture. There will be a pre-lecture for next Tuesday that you really do want to watch before lecture. It will help. I will get that up this weekend. And yeah. All right. That's all I got. I'm going to stop. Send me your mole joke.